All right, so we're doing some revision this morning, starting with this question here. All right, first things first, we have a fraction question. Now, I'm going to show you guys how to work it out step by step. Also, sometimes we could use our calculator as well to work this out. And we take a look at that as well. Now, to begin with, when we're doing fractions like this, we need to convert all of our mixed numbers into improper fractions. Improper fractions is where it's top heavy. You have a larger numerator than the denominator. To do that, we multiply the whole number by the denominator. So for example, 3 by 4 here will give me 12 plus 3 will give me 15 over 4. Now this line here implies division. So I want to rewrite this a little differently. I want to use a division sign instead. Right? It's easier for you to process it that way. And then we're going to use our bracket because underneath here, we have to work this out separately. We have to work this out to get our answer, and then we can divide the 15 over 4 by it. Right? So I'm going to put this in our bracket, and I'm also going to change these mixed numbers to improper fractions. So 2 by 3 will give me 6, plus 1 is 7 over 3. And we have 5 over 6, so I don't need to change anything there. Next line, I'm going to do 15 over 4. Right? We could still use a division sign here for now, but I want to resolve this bracket. Now, I'm going to use something called equivalent fractions to sort out this bracket here, right? So no long lines and finding the lowest common denominator. We simply want to make the two denominators the same, right? We're still using the same concept though of LCM. The LCM of 3 and 6 is 6. That's the lowest possible number that both 3 and 6 could go into. Now, I already have a 6 here, so that's good. I need to make this a 6. How could I make this a 6? I need to multiply it by what? 3 by what will give me a 6? Anybody? 3 by 2, correct. So 3 by 2 will give me 6. But if I'm multiplying underneath here by 2, it means that I also have to multiply on top by 2 as well. So what that would result in getting is 14 over 6. And we can put back our minus 5 over 6 here. And we can put back our brackets. Now, by doing that, we now have the same denominators below. And that makes it actually easier for us to work this out. Because 14 minus 5 is going to give me 9 over 6. And we can leave it like that for now. Now, when we divide in fractions, that division sign has to change to a multiplication. And we flip in the fraction on the right-hand side. So this is going to flip, meaning that the 6 will go on top, the 9 will go below. Now I will decide to cancel. So I can cancel 4 and 6. 2 could go into both 4 and 6. So I'll get 2 here and 3 here. And I could use 3 here. 3 could go into 15 5 times, and 3 could go into 9 3 times. Now that I've done that, right, we could cancel one more time here now. We could only cancel top and bottoms, right? Not across. These 3's here could cancel off. I get 1, 1. That's going to leave me with 5 over 2. Or we could write this as 2 and a half. Everybody okay with that? Yeah? Anybody not okay? I see it or here in our hand. Or there's a hand to say that you're okay. Everybody good, right? All right, nice. Now, what I want to do is I want to look at it on the calculator as well. All right, so this is our calculator here. Most students tend to have the sharp calculator, so hopefully this is easy for you. Right. Now, there's this button here that you see A/B, that's a fraction button. And above it, you'll see B over C, that's improper fractions. Now, if I hit it, what we'll get is this thingamabob here that looks like you have buttons to enter a fraction. Now, you could use this as a toggle bar to move to the different spots to populate your fields. Right, so that's a 3 there, a 4 here. Right, now the important thing is that you need to use brackets. Right, so the 3 3/4 is going on top. We have division, just like I said here. And then we open our bracket, and underneath here, we're gonna do, now to access this orange one, I press the second function button to get this. Right, I need to come back out a bit to put in the 2. Then I'll come on top, I'll put in the 1. I'll go below and put in the 3. Across, minus, second function here to get more fraction button. This one is just a 5 over 6. Come out, close my bracket. Seen it? So I have the 3 3/4 divided by 2 1/3 minus 5 over 6. And then I can hit my equal sign. And you see we have our 2 1/2. If we want to see it as a mixed number, oops. Did I go back? I'll go back. Well, we got 2 1/2. Everybody understand how we we got the 2 1/2 using the calculator? A little thumbs up if you write it down. Yeah? All right. Good. So you understand the use of the calculator to do the fractions, and we worked it out a long way. Part B. BDS means Barbados dollars and EC means Eastern Caribbean dollars. Karen exchanged 2,000 and received $2,700 EC. Calculate the value of 1 Barbados dollars in EC. How are we doing that? Any suggestions? We're going Barbados dollars to EC dollars. 2,000 dollars giving us 2,700. Any ideas on how we're going to find for 1 Barbados dollar? Any suggestions? What do you think we should do? They bounce up something like this in exams. What are you doing? Just now, right, guys? Hi, morning. Hi, morning. Hi, good. Hi, good. What's up? Yeah, I'll send it in a little bit time. I'm class there. Uh-huh. Okay, okay. All right, well, it's maths, business accounts, biochem, and maths. Business accounts, biochem, and add maths. POB, yeah, and POE. All right. Now, is $250 a month. Maths going on right now, and buy you do anything with no, you're not doing buy, you're doing business. I do have a day right now for POP because the Form 5 is gone. That used to be on a Monday evening. Monday evening, from 6:30 to 8. So so that will be a new class starting in September. And yeah, and maths is on a Saturday morning. Well, going on right now, we're doing 9:30 to right now in exam prep. So we're doing 9:30 to 11:30. But usually that used to be 10 to 11:30. All right. No problem. So welcome. All right. Yeah. All right. So no ideas. Nobody have any genius ideas. How are we gonna find out? All right. So if I tell you 5 apples cost $20, and I want to know how much for one apple, what will I do? Divide. Very good, Amaya. Sharp and neutral. Who are dividing? What by what? 20 by 5. And now we give more? $4. Agreed? So anytime we want to find for one, I always wanted to think about this analogy that I give you, right? Because it's the simplest one and everybody can relate to it. If 5 apples cost $20, one apple is $4. Your brain automatically is work it out. And it's work it out because it's taking the $20 and it dividing it by 5, right? Each apple is worth $4. So 4 plus 4 plus 4 plus 4. I think plus 4. I wasn't checking too good there. We do add up to my $20, right? 5 apples. It's the same thing happening here. $2,000 giving more 2,700. So if I want to find out how much $1 giving more, then I'm going to do what? I'll divide. Everybody agree with that? Or thumbs up if you agree with that. All right. So divide those two and tell me what you get. Check it, check it, check it. Drop the answer in the chat as you work it out. You can use your calculators, right? So on this side, this is one Barbados dollar, right? And on this side, this is EC dollars. Anybody get answers yet? Very good. Well done, Israel and Amaya. 1.35. So one Barbados dollar is equal to $1.35 EC. Right? So we okay with this. We get this out. Bam. Part two. If Karen exchanged $432 EC for Barbados dollars, calculate the amount of Barbados dollars which Karen would receive. Right? Now, we have, this is for this was part one, and this is now B part two. We now want to go from EC dollars to Barbados dollars. Now, basically, what we learn is that every $1.35 EC is going to give us one Barbados dollar. So we need to know, we have how much EC we have? 432. So we have EC 432. 1 second, huh? Okay, what's up? EC $432. Basically, every $1.35 will be $1 billion. So we need to know the number of groups, if you want to think about it like that, of 135s we could get inside of here. So what we're doing is doing what? We have to divide it up into groups of 135, $1.35. And how much are you gonna get? I'm gonna see quick on the draw with the calculator there. Answer gonna be in BH and dollars, right? Work it out already? Very good. 320. Very good, Yusra. And that's our answer there. Easy? All right, nice. A credit union. Let's not somebody in the chat. Right. A credit union pays 8% per annum compound interest on all fixed deposits. A customer deposited 24,000 in an account. Calculate the total amount of money in the account at the end of 2 years. Anybody know what is the formula to calculate the amount for compound interest? Who knows that formula? It's a funny looking formula. I'll take a little picture it from on Google and I'll drop it in here for you. So next time when I ask you, you remember, right? This is part C. Right. Now to work out the amount for compound interest, the amount that they receive after a period of time. This is the function. Right? Now, I want to simplify this a little further here. A little further. Where we are going to use, oh gosh. Use this one instead to save you some. This is a little easier for you to understand it. And it's more applicable to the question itself as well too. So let's cut out the question so you can put them next to each other and you see how to extract what you need from it. So they want us to calculate the total amount. The amount is the final amount A. The principal is the amount that the customer deposited. So our principal amount is 24,000. Right? I is the interest rate, 8% per annum. So my interest rate is equal to 8% per annum. And N is my time. Right? At the end of 2 years. So that's 2 years. So using this formula, you can work it out for me now. A is equal to P by, this is a 1, plus I raised to the power of N. So principal is 24,000, open brackets, 1 plus, we could write this as a 0.08 from as a decimal. Right? And number time in years is 2. If you don't want to use a decimal, then you put it as a fraction, 8 over 100. Yeah? So check that from on somewhere again. So is the first to work it out. So inside of this bracket here, this will simplify to 1.08 squared. What's the answer? Nobody work it out yet? Yes, I now see it there. Leo said it. $27,993.60. You want a thumbs up if you got out. That's the amount. Right? So we're done with this. We have a total of 11 marks here if this was an exam. Everybody understand all the questions that we answered here so far? If you were to get something similar, would you be able to work it on your own? Yes? Probably. All right, we're going on again now, right? All right, everybody favorite topic now, algebra. And we're starting with algebraic fraction. What am I going to do here? Anybody knows? I have 2m over n minus 5m over 3n. Now, maths is something or is a subject that you always want to build on your prior knowledge, right? Now, these are fractions. What if I had, for example, 2 over 7 minus 5 over, I don't know, 3? How would you work out something like this? You would tell me, well, say we had to find the LCM. 7 and 3 is 21. You'll say 7 into 21 is 3. 3 by 2 will give me 6. 3 into 21 is 7. 7 by 5 will give me 35. And you'll work it out and you'll get a fraction. Everybody agree with that? Yes? Everybody agree, right? Yes, good. Nice. Now, can we not do the same thing with this? We could do the same thing like this, with this. Now, don't let the letters confuse you, right? You know, 7 and 3, the lowest common multiple is 21. But If you think back to primary school, when we have to find the LCM, this is what we used to do, not so? We had 7 and 3 as two numbers to find the LCM. We'll do what we call prime factorization, and you'll do 3 into this, you give more 1. 7 into this, you give more 1. And once you get all ones here, 3 by 7 is 21. How many people remember this from primary school? To show everything interconnected. Even if you didn't do it in a while, it looks vaguely familiar. Yes? Give me a thumbs up if it looks vaguely familiar. Right. You know it. You see it already in your life before. It's not the first time you've seen it. Well, it's the same thing happening here, right? Basically, we need to find the LCM of n and 3n. Now, we could start with the numbers first. The number that we could start with is a 3. 3 into this 3 here will give more 1. Right? You could put 1 in here. And then we all out of numbers now. So I need to go with n. N into n will give me 1, and n into n will give me 1. The objective is to get 1s at the bottom. And then you'll multiply, find the product of these prime factors here. So 3 by n is 3n. So our LCM of this is actually 3n. Our LCM is 3n. N into 3n is going to give me, the n's will cancel out and I'll remain with a 3. And just like I gave the example before, we have to multiply this 3 by 2m. And that'll give me 6m. And then underneath 3n into 3n will give me 1. And 1 by 5m will give me 5m. Now, I could work out on top of here because they're both expressed in terms of m. So 6m minus 5m will give me m over 3n. Everybody understand that? Right. So let's try one. I'll make up one for you to do, right? Let us use, I will make up one. We'll borrow one from Uncle Phil. Try this one. We're doing 4 over 3p plus 2 over p. Similar to what we do there, right? Both of them have the same p's. You have a 3 there. You have a 4 and a 2 on top. I'll put m back here just to make it similar to what you have on top of it. So we call that one. Right? Just like we did on top, okay? So my LCM of 3p, you have to have representation, if you want to call it that, of the numbers and the letters. You're taking the lowest common multiple for the number and you're taking the highest possible power of the letter. Each letter should be inside of the LCM, the lowest common denominator. So you have a 3 and you have the p. So when I do 3p into 3p, I'll get 1. They'll cancel out each other. 4 over 4 is 1. 4 into 4 is 1. So 3p into 3p will give us same one, remodeling. 1 by 4m will give me 4m. P into 3p, p's will cancel out and I'll remain with a 3. I'm multiplying 3 by 2m to give 6m. I'm multiplying 1 by 4m to give me 4m. Everybody right with this part here? Model thumbs up. We add in 4m and 6m together because they're both expressed in terms of m. They're the same terms. So we can add 4m and 6m and that will give us 10m over 3p. Now look at this other example that I'm going to show you here, right? What if I had something like 5/2a squared plus 2/3ab? Now, don't expect every time we get something like this to go and draw up our prime factorization thing in the column, right? So I want to show you a faster way of looking at it. We need to compartmentalize, meaning that I want you to look at things in isolation. When you do that, it wouldn't seem as confusing. So let's just pretend that all we see in here is the 2 and the 3. What is the LCM of 2 and 3? The LCM of 2 and 3 is 6. That is a number that both 2 and 3 could go into. Give me a thumbs up if you agree with that. Right. Now, each letter must have representation inside of this LCM. Right? So it's like, think about it like parliament. Every constituent or every area must have a representative. Now, you're going to take the letter with the higher power. So between a squared and a, you will take the a squared, not the a, because you want it to be able to go in completely. Right? Now, every letter must have representation. So we deal with the A's, we have to deal with a B. The mere fact that you have a B on this side, even though none is on this side, B must be represented here. So my LCM is 6a squared B. So you see when I break it up and I look at the number first and then each letter, how much easier it is to come up with our LCM? Give me a thumbs up if you agree with that. Right. Now, the next part now is you're taking your LCM and you're dividing it by your denominators. That's what you're doing. So you're basically saying 6a squared B divided by 2a squared. And it can cancel out if that makes it easier for you. So the a's will cancel out entirely. So the figure that you're going to put on top of here not going to have any e's in it. We are canceling this out to get a number to multiply by 5. What is the number after multiply by 5? 2 into 6 will give more a 3. Notice how underneath here is now 1. You want underneath here to work out to be a 1. And then we remain with a b up here. So the number right in here, or the term, is a 3b. Let's do the same thing with this denominator. You're taking the 6a squared b and dividing it by 3ab. Do one thing at a time. 3 into 6 is going to give me 2. A into a squared will give me a. B into b will cancel out. So I get in a 2a here to multiply by 2. Everybody understand how we get the purple boxes on top of here? Yeah? Everybody, right? Anybody do understand? Just give me a thumbs down and I'll look it over. All right, so it's straight there, right? So 3b by 5 now, gonna give me 15. 3 by 5 is 15, and I put back the b. Plus 2 by 2 is 4, and I put back the a. Now, at this point, can we add these two things together? I can't, because this is expressed in terms of b, and this one is expressed in terms of b. So this is my answer. We can't go any further. Everybody all right with that? All right, a simple one just for you to try, and then we're moving on, right? We will come back. So as we do more revision sessions, we will keep touching on the whole idea is somewhat to touch on as many different questions and for you to see how to work them out as much as possible. All right, so we're doing why can't there be cancellation? Very good question. Now, in order to cancel, right, we could only cancel when things are multiplying, not when you have an entire expression like this. Now, if we could have simplified this further, like let's say, for example, let's make up something here, right? Let's just say that I ended up with 12b plus 6a on top. And this was over 6a squared b. This would provide an opportunity to cancel, but I'll show you how. we will have to factor on top of here. You see, when you look at this, the B and the A not common, but 6 and 12, they're common. You could factorize that. If I pull a 6 out, 6 into 12 will give me 2P, and 6 into 6 will give me 8. Now that this is multiplying by this bracket here, we have an opportunity to cancel the 6's. Just like up here, notice that we only cancel because everything here was multiplying. Look at these two here. There was no addition signs or subtraction signs between anything. Everything was written clustered together as a product. When they are products, when they are products of each other, we could cancel. If it is involved with something else like this, where you have the plus in the middle here, you can't factorize unless it is you could divide both terms by that number below. Or you could factor it out like this and then cancel here. Understand? But it must be products in order for it to cancel. Yeah? Everybody okay with that, right? So you can't say, well, all right, I'm going to cancel this 6. Oops. I can't say that I'm going to cancel this 6 with this 4. Because this 4 belongs in our bracket to this 15B. You can't touch this alone and not touch this. Right? You have to touch both of them, or you have to include both of them together if you're doing any cancellation. Yeah? All right. So one more to try, and then we're looking at the other question. So we're doing, try for me, 6 over 4x squared plus 3 over 8x. I try to keep it as close as possible to this one, just so that easy for you to follow. So try this one for. So remember what we did, right? You look at the 2 and the 3 first. Here you're looking at the 4 and the 8. LCM of 4 and 8 is 8. Then you're looking at the x squared and the x. You're taking the higher power. And because y is there, you have to include y. It must have representation for each letter. Yeah? So try that for me. So we're doing this one again. We have, look at the 4 and the 8. LCM of 4 and 8 going to give us 8. X squared and x, you're taking the higher power. Every letter must have representation, so I put in the y. We're doing 4 into 8 to give more. I'm going to do the same way as we did before. We're taking 8x squared y and dividing it by 4x squared. 4 into 8 going to give more 2. X squared will cancel with x squared and remain with our y. So up in my purple box on top of here, I get in 2y multiplied by 6. On this side, if we're doing 8x squared y divided by 8xy, remember, this is the one now going on top. This one going underneath. 8 will cancel it, 8, y will cancel it, y, x will go into x squared. One time and leave a x. So I get in x multiplied by 3. So 2y by 6 will give me 12y. And x by 3 will give me 3x. Yeah? We don't have any opportunities to cancel. Even if we factor on top, which we could, we get 4y plus x. I can't cancel anything underneath here because 3 can't go into 8. Yeah? Everybody okay with the adding, subtracting, or algebraic fractions? Even if we change the plus sign to a negative sign, everything that we did there still holds. Yeah? We good, right? All right. Let's look at B. We have A star B is equal to A squared minus B. This is a rule, right? The name of this topic is called binary equations or operations. And basically, we are defining a rule. The rule we define is that anytime we see A star B, we're going to take the value of A, square it, and minus B. So if I have 5 star 2, the 5 is my A. So we're going to say 5 squared. The B is my 2 minus 2. So I'm getting 25 minus 2 to give me 23. Everybody understand that? So using the same rule, can you find for me 7 star 4? Look out 7 star 4 for me. So same thing like before, right? We're doing, if you want, what I tend to do is I always write back the rule. So A squared minus B. And then I'll put this here so I could see clearly what A is and what B is. So A is 7 squared and B is 4. So again, 49 minus 4, the answer is 45. How many people got that? Yeah? That's excellent. So that's binary operations there, right? So we're touching on going there now. Next one. We're looking at part C. Part C, we have to factorize 3x minus 6y plus x squared minus 2xy. Right? Now, look at this. When we factorize in, you have different types of factorization. You have factoring by HCF. An example of that could be like what we saw above, where you had like 12x plus 3y, and you use the highest common factor, which was 3, and you get 4x plus y. This is factoring by HCF. The second type is factoring by grouping. Right? And a good example of that is something like AB plus CB and DB plus DA plus DC. You always would know when you're factoring by groups because the question tends to have 4 terms. Let's count them. 1, 2, 3, 4 terms. 1, 2, 3, 4. So most likely, this is factoring by grouping. Another hint when you're factoring by grouping is that there's no one factor that can factorize all 4 terms. Can you find one number that could go into all of these or one letter that could go into all of them? No. Right? The other distinguishing feature is that you could find one factor that can factorize a pair. Right? And that's where it's getting interesting. If we do this, look at this. If I put this in our bracket, this is similar to what we did here. There's a factor. This 3 is a factor. We could pull 3 out. Everybody see now? If I put this in our bracket, there's a factor x. We could pull x out. So if we look at them in pairs, we could factorize them in pairs. Everybody see now? So let's do that. I am going to rewrite it. So 3x minus 6y plus x squared minus 2xy. Right? So my first hint was that I have 4 terms. My second thing is that I want to bracket them up like this. I'm going to look at them compartmentalization. We're looking at it in bits and pieces, right? So you're attacking the work on a smaller scale. So let's just pretend like we're just going to forget that it have this on the side here and we're just looking at this. That's what we're looking at to start with. Could we factorize this? That's a simple enough factorization. If I pull out a 3 from here, I'll remain with the x. And 3 into 6 will give me 2y. Everybody see now? Now, once you can do that first, all your headache done. I'll tell you why all your headache done, right? I'll show you a little cheat code here. Now, once you know you're factorizing, and once you identify you're factorizing by grouping, 10 out of 10 times, if the bracket that you have here is going to be or has to be the same bracket on this side. When you factor this, you're going to get the same bracket. So instead of trying to factor it and wasting energy and mental power trying to work it out, just copy the same bracket. You get the first bracket, just write the second bracket one time. Right? All you're going to do next is you need to work out what's going in the middle here. Because there's something that's supposed to come in front of this bracket here. And we need to identify what that is. And to identify what that is, we are going to use this term and this term. Right? Look at it. This is a x, but before it was a plus x squared. So what is missing? I'm missing a plus sign. Everybody agree with that? And to get back x squared, I need to multiply x by x. Plus x by x will give me back x squared, not so? And watch, we could test the other one too. Plus x by minus 2y will give me back the minus 2xy. So you're checking it just to make sure that your logic, your reasoning sound. Now that you have done that, look at what's happening here now. This bracket and this bracket is the same. Everybody see that you have the same brackets? So instead of writing it twice, you're going to write it once. And we're going to take this 3 and x and put that in our bracket. And we could put x plus 3 or we could put 3 plus x. Any one you want to. Everybody understand that? So this was factorizing by grouping. Let's try one quick one fast there. So try for me. Four x squared minus xy minus 8x plus 2y. Are you doing the correct thing here, boy? 4x squared minus xy minus 8x plus 2y. Another instance. Yes, sir. Let me give you a different one. Try this one for so xy minus 3y plus 2x minus 6. You go it out. Right? 4 terms. So you know it's factoring by grouping. You're pairing them up. Pair up, pair up, pair up, pair up. Look at this one. What come on? What come on? Tell me what come on. You check the numbers first. If nothing come on, in the numbers, you check the letters. Correct marker. The Y's come on. So that's what I'm pulling out. Think about it like you're literally taking it up and putting it outside of the bracket. So if you put it outside the bracket, it means that you're removing it from here and removing it from here. What are you getting inside of the bracket? If I take out the y and I put it here and I take out the y and I put it here, what I remain with inside of the bracket? X minus 3. And then remember what I say. Just write it here one time. Write it here one time. And then compare these two. Watch. This and this. What missing? What missing from it? I needs to go outside here in our purple box. What put in the purple box out here? Compare these two. But I want you to put the sign and the number. So look for everything now missing. What missing? This whole thing here missing, right? Agreed? Right, so you put in the plus 2 here. And then it's testing it back. Plus 2 by this. Is it giving it back this? Yes. And plus 2 by minus 3. Are we getting back this? Yes. So it's testing to make sure. Once you do that, what we do next? Write in the bracket once and put in the y plus 2 together. Yeah? All right, well, I end up looking at that one for you. So try from a 9x minus 3y minus 3xy plus y squared. Try this one. Same thing like what we do there, right? Everybody have it now? So let's look at this one. So same procedure, right? We're looking at one identifying as factoring by grouping. We could tell because we see in 4 terms, we grouping them up like this. You're looking at your first one. Look at the numbers. You can clearly see that there's a common factor for the numbers, meaning that 3 could go into 9 and 3 could also go into 3. 3 into 9 will give more. 3, put back the x. But pull out the 3 from here, remain with a y. We say with grouping, just copy the bracket. And if we copy the bracket, I am examining this 3x and up here. What am I missing to put in my purple box outside? I'm missing this and I'm missing this. So I'm going to write minus y here. We double check in. Minus y by 3x, we're giving back the minus 3xy. And minus by minus, giving back the plus. And y by y, giving back the y squared. So we're good. We write in this bracket once. And we put in this 3 minus y in our bracket. And we're done. Everybody okay with that? Yes? All right. We want to look at the other question, all right? Okay, so part D. We're looking at part D. We have a drinking straw of length 21 centimeters is cut into 3 pieces. Now, things like this is always good to have a little. This whole thing is 21 centimeters. And I'm cutting it in 3 pieces. Right. See my 3 pieces? 1, 2, 3. So, the length of the first piece is x. Now, I don't want you to assume that it's even, right? Because the other sentences here telling us something. The second piece is 3 centimeters shorter than the first piece. So this other piece is x minus 3. Everybody with me so far? Give me a thumbs up if you're with me. Right? I don't want the diagram. I don't want you to assume that it's getting cut into 3 equal pieces, right? I just want you to see the 3 pieces. So the first piece is x. The second piece is 3 centimeters shorter. So I'm minus 3 from x. And then the third piece is twice as long as the first piece. So that's 2x. So those are my 3 pieces. We cool with that? Give me a thumbs up if you're okay with that. They said state in terms of x the length of each of the pieces. So my first piece is x. My second piece is x minus 3. And my third piece is 2x. That's for part 1. For 2 marks. Everybody good with that? Right. Writing an expression in terms of x to represent an expression. Does expression have equal signs? No. No equal signs. To represent the sum of the lengths. So we take in each of these. And sum means to add. See what we're doing here? That is representing the sum of the 3 pieces of drinking straws. That's my expression. Now, I want to simplify this a little further, though. Right? We're not going to leave it like this. So I could do x plus this other x here, plus our 2x. So how many x's is that? 1, 2, 3, 4. Agree? So I have 4x minus 3. Give me a thumbs up if you agree with that. Good. Now, remember from the beginning, the length of the piece of straw was 21 centimeters. So the sum of all of these pieces added together, which is 4x minus 3, is equal to 21. So we could find the value of x. Can we find the value of x? Yes, we could solve the equation to find for x. So, copy this sum and solve for x, and then I'll do the solution. I'll write the answer. So the value of x is 6. Good. Let's look at the other question now. We want to some trigonometry. Right. Diagram below, not drawn to scale, shows two triangles, two straight wires, sorry, LJ and NK. So this is LJ here. That's LJ. And NK, two wires. Supporting a vertical pole, MJ. This is the pole here. So this is the pole, and these two wires supporting the pole. LMN, LMN is a straight line on the horizontal plane, meaning as the ground. The angle JML, this angle here is 90 degrees. KNM is 30 degrees. LG is 13 meters. And LM is 5 meters. KN is 10 meters. Calculate in meters the length of MK and JK. So let's look at this first one. MK. Where's MK? MK is this to this. So that is part of this triangle. Everybody agree with that? So my math teacher used to make us draw the separate triangles so you could see things better. And I think he was right in suggesting to do that. So I am going to do the same thing here for you guys. This is 10 meters, KN. This is 30 degrees. They want us to find this. What do we have here? We have a side, KN, and it's 10 meters. We have an angle, KNM, and it is 30 degrees. We want to find KM, and based on our knowledge of trig ratios, this is the side opposite the angle. So this is our opposite. This is our adjacent. This is the side next to the angle. And this is the side that is opposite our 90 degree, and it's the longest line in the triangle, so it is our hypotenuse. Now, when we have a side and an angle, it means that we have to be using our trig ratios. So we're talking about so, ka, twa. Now let's look at what is involved. We have a hypotenuse, so it means that we have to be using one of these formulas that have hypotenuse in it. So this is out. It doesn't have hypotenuse in it. What else do we have or need to find? We need to find the opposite. So I need one of these that has the opposite in it. This does not have the opposite in it. So we are using sine. So I have to use sine. Remember, you have to put theta, that's the angle, is equal to opposite over hypotenuse. This is how we get in so. Now the angle is 30 degrees. The opposite is that side KM. And the hypotenuse is 10. If I want to find km, it means that I have to move this 10 over on this side so that I could remain with km k alone because I want to find what km is. Now, when I move the 10 across, it means that I have to multiply by 10. So I have to go into my calculator, work out what sine theta is, and multiply that by 10. Can you check that for me? Tell me what you get. You drop it in the chat. Work it out already? Yes, sir. You have it, Amaya? What's the answer? 5. Very good. So km is equal to 5, and we just put back the unit of measurement, which is meters. All right, so that's our first answer for 3 marks. Yeah? All right, let's talk about the other one now. The other one, part 2, is you want to find J K. Now look at what is happening here, right? We now know that km is 5 meters. So we need to find this other piece. Now, we just can't find that off of the whim like that, right? The first thing we need to do is we need to look at this triangle here. Let's look at this triangle here, the whole triangle. So I'm going to draw this out just like Mr. Khan, that was my teacher, used to tell us. We take out this triangle. This is L, this is J, this is M, this is 13 meters, this is 5 meters. Now notice there's no angle given here. So when there are no angles and we know we have 2 sides, right? And we want to find one missing side. What we using? Anybody knows? This is our opportune time to use Pythagoras theorem. And the formula for Pythagoras theorem is a squared is equal to b squared plus c squared. A must always be a hypotenuse. So this is A. We could put this as B and we could put this as C. All right. So A going to be 13 squared, B going to be 5 squared, and we're going to work out what C is. All right? So 13 squared is 169. 5 squared is 25. And we have C squared. We move this 169, moving 25 to meet the 169. That's going to give us what? 9 take away 5 will give me 4. 6 take away 2 would also give me 4. And then we move in the square, will become square root. So the length of that side, C, is 12 meters. Now, remember, they want just this little piece here. We just learned that the whole side is 12. But from here to here is 5. So what would this be? 4 J K, we will do 12 minus 5, which will give us 7 meters. Everybody understand that? So we're taking the length of the whole side and we're subtracting this smaller piece from it. Now thumbs up if you're okay with that. Yeah? Right. So that's another one in the bag. Good stuff. Win again. Right, looking at this one now. State the coordinates of P and Q. This is P and this is Q. P, you always go with the X coordinate first and then the Y coordinate second. Same thing on this side here. X first and then Y second. What's my X coordinate for P? If I come down like this, X is what? Drop it in the chat. X would be? What's X? What the arrow pointing to here? Very good, 0. And what is Y? Very good, Y is 3. And what about Q? Q is, X is what? Minus 2, very good. And what will Y be? Y is, we go across this way, 0. See? So for part A, P has the coordinates 0, 3, and Q has the coordinates minus 2, 0. Everybody okay with that? Give me a thumbs up if you're all right with that. Good. Next, they want us to find the gradient of PQ. Now, the formula for gradient, we use the letter M to signify gradient, is equal to y2 minus y1 over x2 minus x1. Now, we could use these coordinates here to identify a x1 and a y1 and a x2 and a y2. We're getting that because you have 2 points, first and second point. So M is equal to y2 will be 0, y1 will be 3, x2 will be minus 2, and x1 will be 0. So 0 minus 3 will give me minus 3, and minus 2 minus 0 will give me minus 2. And minus divided by minus will give me a plus. So we get in the gradient to be 3, 2. Everybody okay with that? Yeah? All right. Equation of the line now. Equation of the line. We have y is equal to mx plus c. That's our formula. We already know the gradient is 3, 2. And we could use any of these points. Let's take the point 0, 3. So this will be my x and this will be my y. So we could substitute these values here now, right? Y is 3. M is 3 over 2. X is 0. And well, we don't know what C is as yet. Anything multiplied by 0 is going to give me 0. 0 plus C will give me C. So the value of C is 3. Now we have to rewrite And we want to fill in the values for m, that's 3 over 2. Put back the x, put back the equal sign, put back the y, and c, which is now plus 3. So this is the equation of the line PQ. Everybody okay with this? Anybody want me to go over the steps, so you're comfortable there? Somebody raise a hand. Okay. So we're going again. You understand how we got the gradient? Yeah, give me a thumbs up. You okay with this, right? Nice. This is my formula. We want to substitute values for here, and for here. M is 3 over 2. I got that from here. And then x and y are taking this from any point on the line. We use any point P. So for my x value, I'm going to use 0. And for my y value, I'm going to use 3. So this is 3. This is the 3 over 2, the m. And x will be 0. Anything multiplied by 0 will give more 0. So they're actually making it easier for us. Because now I'll just remain with c is equal to 3. The equation of a line is always in the form y is equal to mx plus c. But we will usually have numerical values for the m and the c. And that's what we needed to find. We already found what m was, and we use our knowledge of m and the point P, which gave us an x and a y value, in order to work out what c is. So I could write it like this. So these are the only two things that I put in number values for. This will always be a x and a y for any equation of a line. Everybody understand that explanation? Yeah? So we okay with that. Part C now. We're doing part C. They say the point minus 8 and t lies on this same line segment. The equation of the line that we got was y is equal to 3 over 2x plus 3. Everybody agree with that? No. We could use this equation of the line to identify any point that lies, when I say lies, meaning that it's on the line, lies on the line. How? By substitution. What I mean by that? Well, if I know what the x value is, I can find corresponding y value. And I'll show you how. If this is my equation of the line, y is equal to 3 over 2x plus 3. And I have the point, as they gave me here, minus 8t. So I put minus 8, and I'll put a question mark here, right? We don't know what t is. You want to find out. This is the x value. So right here, instead of putting x, I could put what 8 is. And I'll be able to work out what y will be equal to. Because look at this. If I put 3 over 2, and I put in the 8 here now. Put it over 1, right? So you see the fractions. Plus 3. I could work out this entire side and I'll get what y will be equal to. Does that make sense? If I cancel here, I'll get 4. 2 into 8 will 4. 3 multiplied by 4 give me 12 plus 3. Y is 15. So this value here is 15 when x is 8. So t is 15. And I know t is 15 because that occurs when x is minus 8. So if I go on the graph and I put the point minus 8, 15, it will be a point on the line itself. It will actually rest on the line here like that. And it will line up with minus 8 and 15. It'll actually be on top. It won't be below. Understand? Oh, wait. My bad. I forget something here. Big problem. It's not 15 because we were supposed to put minus 8 and upper 8. So this is our minus 12 here. So it's not 15, it's minus what? 9. So don't make that same mistake, right? Check your signs. Good thing I went on the graph because I'm not watching that same. But if you go further this way and it's minus 8, then it had to be lower here, be minus 9. So you line up like that and the point will continue. Understand? Everybody okay now? Anybody not okay? So we okay with this one, right? If you want to find the point on the line, we put substituting x into the equation and work out what the corresponding y value is. All right. Last part of this now, we want to do this one. They say the line segment AB is perpendicular to PQ. So this is another line that's perpendicular to PQ, and it is passing through 6 and 2. Now, we're going to use the same equation or the line formula in order to work it out, right? So we want to find the equation of AB. We know that AB is perpendicular to PQ. That means that if this is PQ, the other line meets it at a 90-degree angle, like this. That's what perpendicular means, right? This will be AB, and this is PQ. Now, there's a rule, or there's a common knowledge about perpendicular lines. The product of the gradients of perpendicular lines is always minus 1. Now, what does that mean? It means that if the gradient of PQ is 2 over 3, right? That's what we got. That's what we got? Double check. 3 over 2. The gradient of PQ is 3 over 2. The gradient of the other line, AB, you always change the sign. So this was positive. This will be negative, and you flip the fraction. So the 2 will go on top, and the 3 will go below. Change the sign, flip the number for perpendicular lines. Now, they also give us a valuable piece of information. They say that the line AB passes through 6 and 2. So AB passes through 6, and 2. This means that the line itself has a point on it that is 6 on my x and 2 on my y. So there's a point, just like how we had write the point P and Q before, that is 6, 2. This is important to us because it's going to provide us with our x and y values. And this is providing me with my m. I need those pieces of information because if we want the equation of AB, remember the formula is y is equal to mx plus c. The m will be this. M is going to be negative 2 over 3. And the x and y will be these values here. So y is going to be 2 and x is going to be 6. I'll put 6 over 1, right? That's our fraction here. And this c is what we're going to work out. We're going to find what c is. So let's see what's happening here. 3 could go into 6 2 times. Minus 2 by 2 will give me a negative 4. Yeah? Bring down my c. Go back my equal sign. Go back my 2. This minus 4 will come across on this side. And it will become a plus 4. You see still on this side here. And 2 plus 4 is 6. So c is equal to 6. So now I could write the equation of AB. Remember, the general form is y is equal to mx plus c. We now know that m is, well, we know that from before. We had say m was the negative 2, 3. We change the sign and flip the number. So I write in minus 2 over 3 x. Remember, you're putting back the x's and the y's. And c is plus 6. So this is the equation of the perpendicular line AB. Right? Nothing different to what we did when we found the equation of the PQ. So every time you find the equation of a line, you always need to know what the gradient is, and you must have at least one point that the line passes through, or one point that is on the line, so that you could have x and y values to substitute in here to find out what the c is. When you're rewriting your answer will always have a number value for the m and a number value for the c. The y and the x remains. You'll always put y is equal to x. You'll always put y is equal to something by x plus c. Everybody okay with this? Clear? Crystal clear? All right.